Tom Rudelius. Welcome to the podcast.
Yeah, thanks a lot for having me. Good to be here.
Did the universe begin to exist? Why or why not?
Um, Probably, I guess is I think the best answer I can give. So there are a number of ways that the universe could have been eternal. So Einstein famously, what he called his biggest blunder was this idea of an eternal universe where the cosmological constant is tuned exactly what it needs to be in order to give rise to a universe that just exists eternally into the past. Turns out that's not even close to the right value of the cosmological constant. The cosmological constant is non-zero, but it's not that particular value. So yeah, so kind of there are a number of singularity theorems, Penrose singularity theorems. There are some uh, theorems involving the beginning of inflation, and basically what all these things seem to suggest is that there's a finite is that there was a beginning of the universe at some finite time in uh, in the past. Now, the reason why I can only really say probably is that what these theorems rely on is classical general relativity, and there comes a point at which, as going farther and farther back into the past, there comes a point where the energies just get too high and physics is no longer well approximated by classical general relativity. And so at that point, you need a quantum theory of gravity like string theory. And at present, we just don't really understand string theory or quantum gravity well enough to understand what may have been happening at that point. Some people try to come up with these models where instead of like hitting a quantum gravity regime, maybe you have some sort of like cyclic oscillation. um, but there isn't really great evidence for any of those things. To me, it's a bit. To me, it's working a little bit too hard to try to avoid uh, uh, just saying there's probably a finite past. So I mean, I think more likely is just we enter this regime where quantum gravity takes over, and we don't really know what's going on. Probably the whole notions of space and time themselves break down. Um, but at that point there's a lot of ignorance, so that's why I say probably. I mean, I think from what we can tell, everything looks like there's like the universe began to exist, but there also comes a point where we can't the laws of physics as we know them don't really help us too much anymore, and at that point we sort of have to throw up our hands.
Okay, so I had an interview with Luke Barnes, who said
Mhm.
pretty much the exact same thing. It was we
Okay,
can say
good.
probably because we don't have a quantum theory of gravity to describe this very first split second in the history of the
Mhm.
universe. But what justifies that probably description? I mean, to my mind, I think the right inference, given only those things that you've said, would be to say we should be agnostic. We just don't know. So how do you have even the probably confidence based upon current physics that we know doesn't apply to that first epoch, that first moment when the universe would have begun to exist? How do we justify saying it
Yeah,
probably did versus saying we have no idea?
yeah. So I mean, I guess it comes down maybe a little bit to semantics. I think what I would say is that there's probably only a finite period of classical time that has existed in our past. So there does come a point where, as I say, quantum gravity takes over. Probably space and time cease to make sense as concepts, and at that point, I guess um, it's maybe not right to say that the universe. I mean, at that point, it kind of becomes tough to even know what to say, right? Once time itself ceases to be a valid concept, I'm not sure exactly what words I should use to describe the universe coming into existence. But what I think I can say, where I'm confident in saying probably, is that what I think is unlikely is this idea that somehow once we get past this wall of ignorance where quantum gravity takes over, that somehow there's more classical time in the past. Like that's something that's logically possible. That our universe, you go back in time, there's some it's some finite time in the past we enter this quantum gravity regime, and then on the other side of that quantum gravity regime, there's an infinite past. That is logically possible, but to me, it's just when you get to a wall of ignorance, sort of what are the odds that what lies beyond that wall is just a mirror copy of what you've come from? To me, that seems rather like it would be an enormous coincidence, and that's where I think that it's unlikely that that's what's going on. That once you get that, on the other side of this quantum gravity regime, there's another infinite, infinite expanse of classical time. So that's where I say I feel fairly confident that that's not the answer. Um, but where I am much more agnostic, and where I'm much more sympathetic with someone who's agnostic, is to just say, well, I don't really know what the physics of the quantum gravity regime is. I think it's unlikely that it's just a mirror copy of classical time on the other side. But given that, I do think that the entire notion of time and space seeks to make sense. Ceases to make sense. I think that's where we should sort of be agnostic as to what exactly is going on there.
So we're talking about the so-called emergence of space-time. Is that correct?
Yeah. Uh-huh.
That at some point in the past, whether it's even coherent to talk about a point in time, but in some sense, space-time is supposed to emerge from a non-spatiotemporal structure. But what does that mean? I mean, I
Well, that's
I think this
you're
is
the
an area.
philosopher, right?
Right,
You're
I'm the
the philosopher,
philosopher.
right? I think you're the one who needs to explain what that means to me.
I was literally just going to say that. I thought if there's ever a time for philosophers to step in and help, it would be in clarifying these ideas, because there's one sense of the emergence of space-time which is just incoherent, and that's the emergence of space-time over time, where we might say that a new species emerges from the prior iteration. That's incoherent. You can't have the emergence of time over time. And then there's a sense in which you might say that space-time emerges in this at a higher level of structure. So for instance, you have a bucket of water, and that bucket of water is wet. But when you zoom in on individual molecules of hydrogen and oxygen, neither of them are wet. And so we might say that wetness emerges as we zoom out to this higher level of structure. Well, that one's not obviously incoherent to say that space-time somehow emerges like that. But I think it was Niayesh Afshordi, or no, I think it was Dan Linford that I asked. And I said, in that case, would we say that subatomic particles are literally non-spatiotemporal? They don't exist now, and it just doesn't make any sense to me. Now, that doesn't mean it's not true, because I'm not a physicist. But do you have anything to add that might add some clarity to this idea that as we go back into the past, we approach this boundary, and there is some sense in which space-time emerges from something that's not spatiotemporal?
Yeah, I don't feel like I really have a lot to add. I mean, I think this is sort of one of many places where it's difficult to know how to go from the mathematics of physics into the metaphysical and philosophical realm. Um, because I mean, when we as physicists talk about like the emergence of space time, what what I think most physicists usually mean is that there's some other theory where, in some limit, this theory reduces to Einstein's theory of relativity, which is the theory of gravity that describes cosmology as we understand it. And this is a fairly common thing within physics. Of you have some theory which, in some limit, reduces to one theory, and another limit reduces to another. So, for instance, like Einstein's theory of general relativity, in some limit, it reduces to Newtonian gravity, which is like the introductory theory of gravity that you learn about in high school or something, where planets revolve in circular orbits, right? Um, or elliptical orbits, I guess. And then in another limit, general relativity reduces to special relativity, which is like Einstein's theory of describing things that are moving very close to the speed of light. So I think that, excuse me, as physicists, what we're talking about, people are looking for, or at least hoping for, is some sort of mathematical theory where um, sort of in a certain limit, in some certain regime of approximation, we get out this classical theory of general relativity that we know and love that describes cosmology and black holes and things like this. But then in some other limit should be able to tell us more about what's going on at the beginning, at like the Big Bang. Um, but I think what's really tough for me to know, especially without actually having that theory in hand, is what is the metaphysical or philosophical interpretation of this? What would it mean? What is the interpretation of a world without space or time? Um, to me, those are really difficult questions to answer, and they're especially difficult given our ignorance about the physics.
Mm. So let me ask you a question as a philosopher and a philosopher of religion. Do you think that there is room, given this ambiguity in the scientific evidence, for a cosmological argument for God's existence? One that builds from the premise that the universe began to exist. So for context for listeners, the most readily understandable version of that argument is that whatever begins to exist has a cause. The universe began to exist. Therefore, the universe has a cause. I'm sure many people have heard of it. And so then the idea will be, well, when we think about a cause of the universe, it starts to look a lot like God. So this gives some evidence for God. Given that we can only establish that the universe began to exist in this ambiguous sense, is that potentially a good argument for God's existence, or should we abstain from affirming that second premise in its fullest sense?
This is sort of the question that I've always had with this. I don't really know the answer. I mean, I've explained why I think that it makes sense that the universe. I think it's more probable than not that the universe has a beginning at some point in the classical past, some finite classical time in the past. But yeah, given this ambiguity, it seems to me that it really does come down to one's understanding of time and one's philosophy of time, and yeah, I guess I've been asked this question in interviews before, and my answer is always just you need to talk to a philosopher about this because I'm not an expert in the philosophy of time, and so I think honestly I think your opinion on this is probably a lot more valid than mine. But I think
Oh,
you
thanks.
have to acknowledge that there's some this is a tricky point, right? That I think it's not obviously yes or no to me. There's some work to be done in understanding the metaphysics of this sort of situation.
Yeah, I mean, I think it just comes down to how we understand the actual, real, physical, metaphysical implications of these models, which posit some sort of imaginary time from which the classical space-time emerges, or whatever kind of non-spatiotemporal phase. And it's just, it's. I don't think we really know yet. We don't even know what the true theory is. We don't even know how to interpret the theories that we have, and then we don't know what the actual final or correct theory will be. And so there's two
Right.
levels of difficulty here.
Yeah. Yeah. Absolutely. Yeah.
Okay, so then pivoting to a related topic, the fine tuning of the universe for life. First, what is this purported scientific fact that the universe is fine tuned for life? What does that mean?
Yeah. So what it means is that if you take the laws of nature as we understand them, and specifically, I should probably say the standard models of cosmology and particle physics, they have a number of parameters. So things like the fine structure constant, Newton's constant, the mass of the electron, the cosmological constant. These are parameters which are just sort of put in by hand, things uh, that are needed to fully specify what your model is, what your physical laws are. And what this fine tuning is this observation that if you were to take these different parameters and adjust them by small amounts, the most famous one is the cosmological constant that's tuned to 1 part in 10 to the minus 120. So if you were to if you were to change its value by just a little bit, um, then what you'd find are laws of nature that just can't support life. So you'd have a universe that doesn't have galaxies, If you start adjusting things too much, you'd have a universe that just doesn't even have like atoms, or that collapses in less than a second. Um, so basically, in order to get the laws of physics to be such that the laws of chemistry are such that the laws of biology can exist and that human beings and intelligent life can exist, the laws of nature seem to be tuned in a very, very narrow life permitting range. And so this is uh, it's remarkable, I guess, no matter what your philosophical or metaphysical or theological views are. This is like a serious challenge, is trying to understand why the laws of nature are this way. But but where this often becomes relevant in theological discussions is some people would say that what this is maybe pointing to is some sort of intelligent designer who's sort of adjusted the knobs of the universe exactly where they need to be in order to give rise to intelligent beings. Because for whatever reason, this designer perhaps is interested in creating a world full of intelligent beings.
So one common objection that really lay people will raise when you describe this argument or this claim that the universe is fine-tuned for life is a question about other kinds of life or very exotic kinds of life. When we say the universe is fine-tuned for life, do we mean carbon-based life or life like us human beings? Or do we mean life of any kind whatsoever? Like, is the evidence that strong that we can make that further claim that any kind of life couldn't exist in the absence of this fine-tuning?
I think, I mean, there are many different tunings, and some of them are maybe you could imagine, maybe this is just pointing us away against carbon-based life or something like this. But some of them, I think, you really can't. So the cosmological constant is an example where, I mean, if it's the cosmological constant is ru- just a little bit larger but negative, the universe collapses in less than a second. If it's a little bit larger, if it's a little bit larger but positive, everything just gets ripped apart by the expansion of the universe. So there's no galaxies, there's no chemistry, right? I don't think it doesn't take too much um, creativity to think about a world that just doesn't even have chemistry and say, I don't think you're going to get an intelligent life of any sort. Forget about our periodic table. You're just not going to get anything to work out. And I think also, I think it's also, when it comes to the cosmological constant, if you want to say that there could exist life in some other corner, that maybe for much larger values of the cosmological constant, there's some other completely different type of life. Now, as I just explained, I don't think this is likely at all. But if that were the case, then I think it would still raise the question of why do we find ourselves living in this very fine-tuned region? In other words, if life arises readily for some other parameter values, why don't we find ourselves living in those values instead of these really fine-tuned ones? Yeah. So in fact, I mean, this anthropic reasoning, this idea that the laws have been tuned where they need to be in order to give rise to life, that actually helps resolve some of the, or at least it may, depending on if you like that, or if you like that explanation. But it might actually be the trick to explaining why is the cosmological constant so small. If the anthropic explanation doesn't work, if there's other ways to get life for other values of the cosmological constant, then we still have this big fine tuning problem of why is the cosmological constant so small. So I think that I think at this point there have been enough failed other solutions of the cosmological constant problem that it seems very likely that anthropics is playing a role. That fine tuning really is the explanation. The laws are the way they are because that's what they need to be in order to give rise to life.
Okay, so let me ask a clarifying point here: the fine tuning versus the anthropic explanation for fine tuning. What is the anthropic explanation of fine tuning?
Yeah. Okay. Good. Yeah. So there's a number. I mean, people have tried to come up with lots of explanations, right, for how to explain fine tuning. Like maybe the laws just are the way they are because that's what they because logically this is the only sort of this is the only set of laws that makes logical sense. And so a number of these ideas have been put forward, but in the end, I'd say they've really all been discarded. I mean, there's I deal with all sorts of crazy universes on a daily basis that don't give rise to life, right? Like it's not logical necessity. It's not that there isn't actually fine tuning. There really is. So so the anthropic explanation is this idea that again maybe the laws are the way they are because that's what they need to be to give rise to intelligent life. And I guess from here, kind of, there's two ways to explain this. And this is really where you're going to get a divergence based on theological views. So the first one that I mentioned is for a theist might say, well, maybe God or intelligent design or whatever you want to call it has tuned the knobs in order to give rise to life because this intelligent designer is just interested in a world with life. And so hence, of course, we find ourselves living in this world where the knobs have been adjusted because our world has a purpose. We have a purpose as intelligent beings. The other idea, which is usually kind of the more atheistic view, is, well, maybe there's a zillion universes out there, and they have different laws in them. So most of them are going to have laws that just don't permit life. The cosmological constant is either too big or it's too negative. But by chance, some universe is going to fall into a life permitting range, and then by so-called anthropic selection, since we can only be alive in a universe that permits life, we're going to measure values of the parameters that happen to be life permitting. And we might say, wow, how did we get so lucky? But maybe we're not lucky. Maybe there's actually just zillions of other universes out there, and we happen to find ourselves living in one of these life permitting ones. So I guess both of those could be called anthropic reasoning. In both cases, you're saying that the laws are life permitting because, well, that's what they need to be to permit life. But in one, it's just sort of random chance that this happens to be that universe. That's the atheistic view. And the other, and then in the theistic view, it's not random chance. There's actually some meaning. There's some purpose. There's some higher being who's tuned the laws in order to give rise to life.
I think that's right. Their anthropic explanations in a broad sense. I just know that some people use an anthropic explanation to mean a very specific kind of dismissal, really, of the need to explain fine tuning, with the simple point that we could only exist in a universe that is fine tuned for life. We couldn't have observed a non finely tuned universe, and that's it. So they don't even appeal to a multiverse. They just think, given that selection effect, that's all there is to fine tuning. And I think that's clearly wrong. I think most people think that's wrong. But philosophers like Elliot Sober will say something similar to that. That just given the fact that we are here as observers and couldn't have observed anything else, that's it. Now I think that's mistaken, but some people say that.
Yeah, I guess that's what some people call like the strong anthropic principle. The one that I just described is sometimes, I guess, called the weak anthropic principle. There's probably a lot more anthropic principles, but roughly speaking, strong and weak. Yeah, I agree that. I mean, the strong one just doesn't make any sense to me at all. I think there's this argument. I think it's from like John Leslie or something, a philosopher, that if you imagine that you like are subject to a firing squad, and all these people, all the soldiers line up and they take fire, and they all miss. You're perfectly well within your rights to say, well, they must have missed, or I wouldn't be here to observe it. But that doesn't really explain anything, right? Like, you're still well within your rights to ask the question, okay, but why did they miss? And I think that's the same thing with the anthropic principle is, yeah, sure, okay, fine. The laws are what they need to be to give rise to life. Otherwise, we couldn't be here. But also, like, why are the laws this way? I think that's still a perfectly valid question to ask. I think it's one that we all should ask.
Mm. Well, before looking at those different explanations of fine tuning, one objection that's more an objection to the fact of fine tuning itself is to say that while our current theories of physics have these fine tuned parameters, nevertheless, for all we know, the final theory of physics, the true and complete theory that we will hopefully one day discover, for all we know, that theory does not include any free parameters. Rather, when that theory comes into view, we will see that we can derive the values of all of the various constants and even initial conditions, such that a non-life permitting universe isn't even physically possible. Rather, these values just follow from the underlying theory. And the reason that I think that response has some plausibility is that we know, as you said, that current physics is incomplete. We know that quantum mechanics and general relativity are incompatible at some level. And so, unless reality contains a contradiction, there is a true theory of physics that captures them both. But given that we don't have that theory, how do we make the projection from current physics is fine tuned to therefore the complete true theory is fine tuned as well? Physical reality itself is fine tuned. What justifies that leap?
Yeah, so I guess there are a couple of things that one could say in response to this. So first of all, I guess we've understood physics over the last few hundred years at an increasing level of precision and fundamentalness. I don't know, for lack of a better word, that you go back a couple hundred years and there's Newton's laws, and since then we've come up to understand things about quantum mechanics and general relativity, and so we're understanding nature at a more fundamental level now than ever before. But fine tuning has really kind of chased us all the way down. That even our most fundamental theories of physics still have fine tuning. And so I think that um, you sort of basically, if the universe isn't fine tuned, it's sort of been assembled in such a way as to fool us into thinking that it is, which seems to me kind of implausible. Another sort of related thing to this is that you're right that we don't yet have a completely fundamental understanding of the laws of nature, but yet like we can still talk about the physics of gravity and planets orbiting around each other. We can still talk about how an airplane takes flight. We can still make predictions for particle experiments at the Large Hadron Collider. And the reason why all these things work is because physics has this phenomenon called scale separation, where physics at one distance scale is different from physics at a different distance scale. So, like for big distance scales, you have general relativity, and then you have Newtonian gravity, and then for small distances you have quantum mechanics, and all these things work really, really well in their own domains of validity. So, if we want to talk about, we don't yet have the full picture of physics. That's true, but we do have a picture that actually works really well over a broad range of distances. Like Newton's laws are incredibly, incredibly good as long as you don't start dealing with things like atoms or things like black holes, right? Like the laws of physics work very well. And so some of the problems, and especially the cosmological constant problem, is so bad that if there was some quantum gravity theory that was going to swoop in and save the day, you really would have expected, I think, to see manifestations of that new theory already at distance scales that we can measure. That already you should be seeing, particle experiments at the LHC modified by these modified rules of quantum gravity. So, um, so, so is it possible that there's some other theory? Yes, but it's definitely, if so, if the hierarchy problem isn't actually a problem, if the cosmological constant isn't actually a problem, it's very remarkable that somehow the solution has evaded detection, I guess. That somehow our laws of physics as we understand them don't manifest those solutions. And finally, the last thing I want to say on this is that I think there's, if you want to solve these, if you want to say that, maybe there's some fundamental theory out there which actually predicts these particular values, right, without fine tuning, it's not enough to just say that there's a fundamental theory out there that predicts these values, that predicts values for the parameters. It's that it also somehow needs to predict the correct values of the parameters, right? So I personally think it's very unlikely that there's a theory of quantum gravity that uniquely fixes the cosmological constant. But even if there is, it's not that just that you've got to uniquely fix the value of the cosmological constant. You also have to fix it to be 10 to the minus 120. And so that's the extra step. That's the maybe where there's some hidden improbability in this. You can't just, I think, say, well, this magical theory is going to come in and save everything, because the improbability there is that not only does magical theory exist, but also that that magical theory has the ability to save everything. And so I don't think it might help a little bit, but I don't think that by itself is really going to move the needle, and really going to is really going to move the needle on the improbability here. There's still a problem that somehow needs to be dealt with.
Mm. Well, you piqued my interest. What is the hierarchy problem? What does that refer to?
Okay, yeah. The hierarchy problem is sort of similar to the cosmological constant problem. If the cosmological constant problem weren't a problem, I think the hierarchy problem would be the one that everybody talks about. It's just that the cosmological constant problem is so bad that so the hierarchy problem is really a question of why gravity is so much weaker than the other fundamental forces. So the strong force, the weak force, the electromagnetic force um, are just a lot stronger than gravity is. Another way to say this, if you look, delving deep into the particle physics, the question is, why is the mass of the Higgs boson so light compared to the Planck mass? Like, it's lighter by 16 orders of magnitude, and so I guess it's the same. It's a similar sort of thing where when you do the calculation in quantum field theory, you would expect the cosmological constant to be somewhere near the Planck scale, and you would also expect the Higgs mass to be somewhere near the Planck scale. So so it's like in both cases, this calculation is giving you the wrong answer by orders of magnitude. And the hierarchy problem, part of the reason why it's been discussed a lot in recent years, a lot of people were hoping and thinking that the solution to the hierarchy problem would actually come from supersymmetry that would be discovered at the Large Hadron Collider. So the Large Hadron Collider, which has been going for the last 15 years or so, people were thinking, once we turn this thing on, we'll just see all this evidence of supersymmetry, because that offers a really nice and elegant solution to the hierarchy problem. But we still have yet to see evidence of that. And so at this point, it's sort of getting harder and harder to come up with a solution to the hierarchy problem that doesn't involve fine-tuning. Now, the cosmological constant problem is like that, only much, much worse. And this is sort of what I was saying, is that, if nature wasn't fine-tuned, it was assembled in such a way as to fool us into thinking that it is. We're just getting there right now with the hierarchy problem. Like, there could have been a nice, elegant solution of supersymmetry that we could have found evidence for in the last 15 years. And we might have said, okay, you know what, this actually wasn't a fine-tuning problem after all. At this point, solutions to the hierarchy problem are getting quite fine-tuned. And any solution that you might want to write for the cosmological constant problem is like much, much worse. Like, it was already ruled out by data probably decades and decades ago. So so that's where I say, I mean, it's, people have really tried hard to come up with theories that would answer these questions and resolve these fine-tuning issues. And I think our inability to do it is probably just pointing us to the fact that there is fine-tuning in the laws of nature.
I have a technical question that's been bugging me for a while, and I may not get the chance again to ask somebody. But when physicists talk about the fine tuning of the cosmological constant, it's my understanding that there are different kinds of fine tuning that one might have in mind. And it's not necessarily fine tuning for life. Like, a theory in physics can be
Yeah.
fine tuned, but that
Yes.
doesn't mean we're talking about anthropic fine tuning. So
Yeah.
when a physicist talks about the fine tuning of the cosmological constant, it's been explained to me that it has something to do with different contributions to quantum fields that cancel out to this extraordinarily small degree. And we wouldn't
Yeah.
expect that. We would expect it to be either 120 orders of magnitude larger or in the negative direction.
Yeah.
And they just happen to cancel out to this very small positive value. Is that this? Does that map on one-to-one with the way that the cosmological constant is fine-tuned for life as well? Because I could imagine That you, even if there were no
Yeah.
fine tuning for life, say life could exist at all values of the cosmological constant, negative and positive, one would still have a fine tuning problem. This cancellation to this small value doesn't make sense. So what is the distinction here?
Yeah, that's good. That's a really good point. I'm glad you brought that up, because I think a lot of people, I think that's not very clear in a lot of the discussion. Yeah, so you're absolutely right that that when we talk about, I mean, the cosmological constant being fine tuned, in principle, this has nothing to do with intelligent life, right? What it really is, as you say, there's kind of the way that this is computed in quantum field theory is that there's a sum of two contributions. One comes from the radiative corrections due to your quantum fields, and that's something that you can estimate in quantum field theory, and you get something 10 to the 120 orders of magnitude larger than what we observe. Then the other thing that you can't compute in quantum field theory, you should understand it as just coming like from ultraviolet physics that you don't really know about. So you just kind of stick in some number by hand, and the sum of those two numbers is what we observe. So the coincidence here, the fine tuning problem, is that somehow that the thing that you can compute and the thing that you can't compute, which in principle are from coming from totally different regimes of physics, cancel miraculously. So that's the fine tuning problem, and as you say, it has nothing to do in principle with life. Sort of the miracle, if you will, the remarkable coincidence with the cosmological constant problem is that in this particular case, what people found when they started looking into it is this fine tuning, this cancellation, also coincides sort of with this fine tuning that's needed in order to give rise to life. This was from Steven Weinberg, his like famous 1985 paper, where he showed that if the cosmological constant is a bit larger, just by an order of magnitude or so, that you just can't get galaxy formation. So that's what he took as sort of a prerequisite in order to get intelligent life. If you're going to have life, you need like galaxies for life to exist in. And so what he showed is, see, if the cosmological constant is a little bit larger, we don't get galaxies. So so yeah, so this is kind of going back to what I was saying earlier, that that the whole fine tuning for intelligent, this anthropic reasoning, here it actually is solving a fine tuning problem. The fine tuning problem, which has nothing to do with life in principle, is just why do these numbers cancel to 120 orders of magnitude? First 120 decimal places, these two numbers agree. Why? And they cancel out. Why is that? That's where the anthropic idea of Steven Weinberg comes in and says, okay, well maybe this has to do with intelligent life. Maybe intelligent life is the answer. That if we didn't have this remarkable cancellation, we couldn't exist, so we couldn't make an observation. So the existence of intelligent life is the thing that explains this fine tuning. But yeah, in principle, when physicists talk about fine tuning, they're not talking about fine tuning necessarily for intelligent life. And sometimes some people might say that the anthropic ideas are the things that are going to solve that are going to give us the solution, but they're not the things that are causing the problem. The problem is coming just from the math. Yeah.
Okay, that's very helpful. On a related note, though, of understanding and justifying the claim about fine tuning, what fact of physics or thought process in physics establishes the comparison of possible values for whatever constant or quantity one is talking about? So what I mean is, when we talk about the fine tuning of the cosmological constant or the gravitational
Mhm.
constant, or the fine tuning of the neutron mass relative to the proton,
Mhm.
broadly speaking, we mean that the range of life permitting values for those magnitudes is very, very small compared to the range of possible values.
Yeah.
But what determines what the range of possible values are? And my question then is, with the neutron mass, for example,
Mhm.
seemingly the neutron could have had an infinite range of masses from 0 to
Yeah.
infinity. And so then it just no longer becomes meaningful mathematically to talk about the comparison of a finite range to an infinite possible range, you run into all sorts of trouble. But that's not what physicists seem to be worried about. They do talk about fine tuning, but not to an infinitesimal degree. They seem to have in mind a finite life permitting range compared to a
Yeah.
large but still finite possible range. Where does that come from?
Yeah. I feel like it's tough to be really precise here, because we don't really have like a precise, um, like interval over which the cosmological constant could take values. We don't really know like what is the largest value that one of these parameters could in principle take. Um, so it's I mean it's tough to say. Like I don't think we can say that the odds of this happening are 1 in 10 to the whatever. Like there's not a precise measure that we have on these sorts of things. But well, so I guess there's two ways to do this. One, which is what one of my collaborators has said in a talk before, is that defining fine tuning is a little bit like defining pornography. There's that like famous quote from the U.S. Supreme Court justice that like I know it when I see it, and I think that's kind of often the case with fine tuning. Is like we sort of know it when we see it, but it's not entirely trivial always to define exactly what it means. Um, the thing I would say though is that a lot of these parameters sort of there's bounds based on just assuming that we have a quantum field theory that makes sense, that where we can do calculations. So for instance, I mean, if you take like the fine structure constant, which is alpha equals like 1 over 137, if you were to make it large so that it gets larger than like order 1 or something, at some point you just are going to lose perturbative control, at which point you no longer have a theory that basically makes sense. So that arguably puts sort of an upper bound on this. And the same thing with the cosmological constant. You could arguably say that it needs to be less than the Planck scale, because if it's larger than the Planck scale, then we just never have a weakly coupled like description of quantum gravity that makes sense at low energies, because the energies are just too high that we're only ever in a strongly coupled regime. So I guess you could kind of say that if we assume that we have some theory that has theoretical control where we can do calculations that make sense, that'll give us some sort of upper bound on these parameters. But yeah, as I say, it's not going to be super precise. This isn't these problems aren't maybe well posed at the level of mathematical rigor that some might. On the other hand, all of quantum field theory is not at the level of mathematical rigor that like a mathematician would like. So at some point, it's just sort of this is a mystery. There's clearly some sort of cancellation going on here. Something is remarkable, and we may not know exactly how to define it or put a measure on it, but something is going on. And in the past, sometimes these fine tuning things have led us to new ideas and new solutions. So definitely, sometimes fine tuning is pointing us to something that's real.
Okay, so let us say the universe is fine tuned for life. Let's grant it. Well, what's the best explanation, in your opinion, of that fact? Is there a good design argument here for God, for a cosmic intelligence?
I think there is. I mean, I think that this is, and we started out by talking a bit about the like cosmological argument. I think, and I think I'm in pretty good company when I say that, like, among theistic physicists, we're not really sure so much about what to say about the cosmological argument. But fine tuning, I think, is legit. I mean, it's not an I would say it's not a watertight or knockdown argument for the existence of God. But I do think that the existence of God is at least as good of a solution. I would say a better solution than anything else. In my mind, kind of the only two explanations that I'm really happy with at all are either some sort of designer or some sort of multiverse. And I think that ultimately, ultimately to me, the question really comes down to how good of an explanation is the multiverse. And I think that the multiverse just doesn't, it's a nice idea, but I think it really doesn't get at the heart of the issue, because it's all well and good to say, maybe there's an infinite universe out there that has, and you have enough universes, you have enough monkeys and enough typewriters, eventually you get Shakespeare. If you have enough universes, eventually you'll get life. But the challenge, I think, has always been, it's never just about getting observers, conscious observers, although that may also by itself, that may not be something that is is possible just from the laws of nature alone. Like consciousness might uh, require something more than just laws of nature. But even if it does, I think the real challenge is getting not just observations, but really intelligent observers who are biologically evolved, who can interact with each other in meaningful ways, who seem to have free will. Whether or not we have free will is another question, but we certainly seem to have free will. We seem to be able to make moral choices and face moral dilemmas. We seem to exist in this world that has these moral values and duties, good and evil, emotions, love. These are the sorts of things that I think that are really the challenge um, for the multiverse, because they say it's not just enough to get observations. You have to say that a typical observer looks like us. This is the so-called measure problem of the multiverse, and there isn't really a solution. I mean, people have ideas, people have hints, but I think to quote Nima Arkani Hamed, a physicist who was at the Institute for Advanced Study where I was for a bit, really the multiverse isn't a theory; it's a cartoon. It's our idea of what might be going on. And I think until you actually have a theory of a multiverse that solves the measure problem, that predicts that most observers are like us, and that's the sort of universe that we should expect, that this is the most typical sort of universe, um, I don't think the multiverse really gets to the heart of the problem.
Good. Okay, so what is the measure problem? I mean, I have
Yeah.
some background here, but for listeners, what is the measure problem that faces the multiverse? And I know it's a little complicated, but what
Yeah.
state?
Yeah. So, I mean, so first of all, let's talk about the term measure. Um, to a mathematician, the term measure is equivalent to the term probability distribution. So, so maybe a better way to call this would be the probability distribution problem. And the problem is this: that um, sort of the most common way to build a multiverse in um, in physics, which involves some combination, usually of like string theory and eternal inflation. Two speculative theories of physics, but let's put that aside for now. Let's assume they work out. The problem with the multiverse that it gives you is that you don't just get a very large collection of universes. You get an infinite collection of universes where anything that can happen does happen an infinite number of times. So to try to put a probability distribution on this, um, it's sort of like you sort of have, I could ask about something really wild happening. Like, what is the probability that I spontaneously combust in the next 5 seconds? Well, you might say, well, that seems really, really unlikely, right? Like, I'm not about to just spontaneously combust. But in this multiverse picture, what we should do is to figure out the probability, we should divide the number of universes where I spontaneously combust with the total number of universes. Um, and the problem is that in this multiverse, both of those are infinite. So you're dividing infinity by infinity. That's not good, right? What you need is some way to like regulate these infinities. You need some way to put a probability distribution on here that will give answer. Well, they will give an answer, but not only do you have to give to come up with a probability distribution that will give an answer. Presumably, the answer to that should be very low, right? Like the probability that I get should be very low. And similarly, when it comes to this question of intelligent life, it's not just enough to say that life could exist. What you need to say is that of all the ways that life could have happened, that that on average, typically, what a typical observer, a typical being will experience is similar to what we're experiencing on Earth. Because if there is some enormous number of observers that are of a different type, right, or perhaps Boltzmann brains, these self-aware beings that just fluctuate into existence and then out of existence. If you're getting way more of those types of observers than you are of observers like us, then your multiverse theory is wrong, right? Because it's predicting something that's not observed. It's predicting the vast number of observers should be like X, when instead what we're observing is that a typical observer is like Y. So that's sort of the heart of the issue, is that you need to not only say there is a multiverse, not only does a multiverse exist, not only can we find a way to regulate these infinities to somehow get sensible answers that aren't just infinity divided by infinity, but also the answers need to look like what we actually observe, right? Like they need to agree with observation, or otherwise it's ruled out the same way that any scientific theory is. If it doesn't agree with observation, then it's wrong. So I think that the really hard part of the multiverse theory, it isn't just saying, well, maybe there's an infinite number of universes. I think long before we knew about eternal inflation, long before people talked about the string landscape, it was not hard for an atheist to just say, well, maybe there's lots of universes out there. After all, if there isn't really a great reason for this one to exist, if our universe just exists as a brute fact, I'd say, well, why couldn't a lot of other universes just exist as a brute fact? That to me was never the hard part. It's just of just postulating more universes. The hard part is, and always was, how do you make it so that this is a typical universe? A typical observer will observe a universe like this. That's the measure problem. That's, I think, that's always been, and that is still the problem with the multiverse, which is why I think Luke Barnes says it well. It's somewhere in one of his writings or one of his books, that a multiverse may yet solve the problem of fine tuning, but it won't be an easy solution. Multiverse is not a magic word that makes all the fine tuning go away.
This is just off the top of my head as I was listening to you describe the measure problem, but it occurs to me that possibly the measure problem is only a problem for the multiverse as a scientific theory, but as a metaphysical proposal about explaining fine tuning, it might be that it doesn't really matter if we have a solution to the measure problem. So, what I mean is that the measure problem is a problem because it calls into question our ability to draw out predictions from a multiverse. If we can't compare infinities and regulate them, as you say, we can't determine what a typical observer would observe, and therefore we can't test the theory. We can't draw out predictions of what we ought to observe. But let's just say there is an infinite multiverse. Let's say we're doing metaphysics and we want to explain fine tuning. Just like theism isn't a scientific theory, it's a metaphysical theory. So let's say we're in this infinite multiverse. Well, then it seems to me that even without a solution to the measure problem, the explanation for fine tuning still goes through, because in this infinite ensemble, you will have fine tuned universes that just appear by chance. And then, given the selection effect, the fact that we couldn't observe any other kind of universe, well, therefore, that's the explanation for a fine tuned universe. Whether it goes on to succeed as a scientific theory would be an open question. Now, that might not be right. I might have made a misstep there, but do you kind of see what I'm getting at?
Yeah, I think so. The challenge, though, I guess, I think where it still sort of falls short is, like, remember, there are other solutions here that one could turn to. So, for instance, one could say maybe fine tuning is just random chance, right? Like, maybe there is just this one universe. The laws happen to have fallen into this life permitting range. That I think it's logically possible, right? Now, I think it's incredibly unlikely, right? For all the reasons I've been explaining over the last hour, I think fine tuning is real. I think it's a real challenge. I think it deserves a solution. But you could fall back on that, right? And so I think when it comes to the multiverse, what you really want to say, what you need to say, is that it's more likely than than just random chance being a solution, right? So I think when you want to start to compare probabilities of these different things, the measure problem has to play a role. Like it is important because it what it deals with is what is the probability that this that we are typical observers in this multiverse, which is very closely connected with the question of what is the probability that this actually solves the problem, right? So, like, if we want to compare these different solutions, we need to talk about how unlikely they all are, and I think that's true even at a metaphysical level, even if we're not primarily concerned with making observations for our real world like a scientist. I think if we want to try to assess how good this is, we still need to take into account this measure problem.
Hmm. Well, and it occurs to me that the Boltzmann brain problem, which is related to the measure problem, would threaten to undercut the self-selection effect, because the Boltzmann brain problem is roughly that a single brain that fluctuates into existence in an otherwise empty world of chaos and non-structure is far, far more probable or likely than our entire fine-tuned universe arising. And so there's a sense in which if we can generate a sensible measure, that Boltzmann brains would be the typical observers, but they would not exist in a fine-tuned universe. And so the problem for multiverse theories that do have a sensible measure is that they would lead us to expect that we are Boltzmann brains because those are just far more likely. But then if you can't make any sort of sensible probability judgments and compare Boltzmann brains to normal observers, well, then you have no way of making, in the metaphysical scheme, that further step that in an infinite multiverse, well, of course we observe a fine-tuned universe because these are the only ones we could observe. Well, that's not true. So maybe it is the case that without a solution at the measure problem, there's no sensible multiverse explanation for fine-tuning. I'd have to think about that.
Yeah. I think I agree with that, but
Okay.
yeah, it's a tricky question for sure. Yeah.
So in all of our assessments, though, of explanations, it's always comparative. So we have the multiverse, but we don't assess it in an absolute sense, at least not
Yeah.
in a fundamental kind of way. We are, even if implicitly, comparing it to other explanations, because even if the multiverse is a terrible explanation, it may be the best one we've got.
Yeah.
So that raises the question of how does it compare to design as an explanation for fine tuning? And so why think that? Well, first of all, what is the design hypothesis? How would you specify it? And why do you think it makes fine tuning any more likely than random chance?
Yeah. So I mean, I would say, I mean, the design hypothesis ultimately is that there's a designer out there who, or maybe I should say, which has chosen to make a world full of intelligent beings. And you could imagine different reasons why a designer would do such a thing, right? You could imagine, for instance, that such a designer is just like a kid in some hyper advanced species simulating our universe on a computer or something like this, right? Um, so the design hypothesis by itself doesn't necessarily um, tell us much about this designer, other than perhaps this designer cares about worlds full of intelligent beings, that he or she or it has a preference for such worlds. I think, to me, that ultimately, what when it comes to assessing these different theories against each other, what's going to come into play here, inescapably, is what are our prior probabilities. So I've had discussions with atheists where they just think the design hypothesis is a lot worse, And what it really just boils down to, I think, is that their prior probability for theism is just really, really low. Um, and as I say, I don't think the fine tuning argument is like a completely watertight knockdown argument. If your prior probabilities for theism are really low, then maybe you don't like it, or maybe you do like it, but you say, well, this is pointing to me to some sort of kid on a simulator, on a simulation, some computer and some advanced species, which is simulating our universe. Um, for me, this is where I think the fact that I think some of the other arguments for theism are compelling. That to me, I guess I would say my prior on theism is at least as high as my prior on like a multiverse solving fine tuning. And so I think that if the God of theism exists, that it's sensible that such a God would want to create a world full of intelligent beings, full of intelligent moral agents, and and I think then that really the way that this solves the question is that we should really be asking different questions of theism if we're trying to figure out what is typical on theism versus what is typical on any theistic multiverse. um, and the difference, I mean, what it really comes down to is that on a multiverse, sort of by definition, just doesn't care about intelligent beings, that we are just accidents, that we may have come into existence by random chance, uh, if that's what the measure, because that's what the measure has predicted, just sort of by randomly, that it predicts worlds like ours. Whereas I think on theism, it's a lot easier to make a case that a God creating a world would create a world that has intelligent beings with the properties I mentioned before. That we have this ability to reason, that we are intelligent beings, we can interact with each other in meaningful ways, that we seem to have free will, we seem to have moral values and duties. That those are the sorts of things that, at least I don't lose any sleep at night thinking that maybe that's the sort of world that a God would create. And so I guess that's sort of the difference, is that I think that these features are just very remarkable coincidences on the hypothesis of a multiverse, whereas I think that they're reasonably likely, at least on the hypothesis of theism.
You're right that the usual chain of inference for thinking that fine tuning has a higher likelihood given theism than random chance is that God would, at least to some degree, be likely to create a universe with life, because that would be a good thing to do. It allows for all of those moral values that you delineated. But the common counter retort is that if we say that God would likely create life, because life is good, and therefore fine tuning follows from that, it's a prerequisite for life. Why is so much of the universe hostile to life? Life is exceedingly rare in the cosmos, and life can only exist on the tiniest sliver of this gargantuan universe. I mean, in the reaches of empty space, for example, life can't exist; it'd be immediately torn apart. So why are the conditions for life in our universe such that complex life can only exist in the smallest fraction of this whole expanse, where most of it's devoid of life entirely? Doesn't that seem unlikely? Therefore, if our justification for thinking theism predicts fine tuning goes through, it would seem to also predict that the universe should be chock full of life.
Yeah, I mean, I think I've heard this argument before. I don't think it really, when you think about sort of what the logical, when you take it to its logical end, um, the idea that if God cared about life, that our universe would just be like crammed with living beings from beginning to end and start to finish. I think it's really unclear that that would be a better world than a world that has some life in it. I mean, what's really at stake here, I mean, what's really being compared here when you talk about fine tuning is sort of the conditions needed to give rise to life somewhere in the universe, not the conditions that are needed for life in like a given particular patch of our universe. I think that you know where this uh, sort of the idea, and this is sometimes brought up that like why would sort of God care about us? We're just such small beings in the grand scheme of everything that's happening. But I care a lot more about like my the like transistors that make my computer work than I do about most distant galaxies. I think that in general, like size is not a very good measure of moral value. And so, yes, like you could imagine a world maybe where we humans are just way bigger and we're filling up the entire, the cosmos because we're so large. But I think it's a mistake to think that if God really cared about us, we would therefore be bigger. Because I think it's a mistake to think that if something is small, then therefore it's not valuable. Um, I think that one could also maybe make the argument that ultimately the size of the cosmos um, is meant to tell us less about ourselves and meant to tell us more about like the greatness of the God who's created all of this. Um, that I think I think like one of the really remarkable things when we talk about fine tuning. Um, one aspect I think that doesn't really get discussed a lot is that our world seems to not only be in some sense fine tuned for us to exist, but also in some ways fine tuned for us to be able to study the world that we live in. Like it isn't obvious that we as a species should have the intellectual capacities to actually like do math and do science and build telescopes that can study the earliest parts of our universe. It's really remarkable. And again, sort of a coincidence that our night sky is transparent, right? So that like people, we for thousands of years could look out at the night sky and just like marvel at how big and amazing this universe is. So I think in some ways, the fact that, so much of this universe is not inhabited by us, um, I think in some ways it actually suggests that maybe that we have like a purpose in life to be able to look out at this and to study it and to ask questions about the rest of the world. So I don't think the existence of like non-life permitting patches really should bother us that much, but maybe it should point us to some other aspect of God.
Mm. I think you're entirely right. I think that this isn't an objection usually raised at the scholarly level, but it's a common layperson reaction. And I think answering it and figuring out why it doesn't derail the fine tuning argument does uncover several insights, which are important, such as the ones that you've outlined. So I think it's still a worthwhile question of, well, what could it signify? And I also think it points to the fact that the fine tuning argument doesn't require the premise that the only purpose of the universe is intelligent life. It merely requires that one of the designer's purposes was bringing about life. And I think
Yeah,
that's a point
that's what
that's
I
not
should have
often
said. That's what I
emphasized
should
enough.
have said. Yeah,
Oh no,
yeah,
no,
no,
I
very well said. Yeah, yeah. Uh-huh.
it's just one that it's come up in a different context. I have a paper under review looking at fine tuning and the gap problem. So how do we go from there is a designer to that designer is God? And one argument that was published but didn't really receive any attention was a paper that argued that actually the fact of fine tuning is evidence against a deity or a perfect being, and it points to an imperfect designer. And I don't think that argument works, but one of the points that arose as I thought about this was that there's just no reason within the logic of the fine tuning argument that would allow you to go from the conclusion that the designer designed the universe to bring about life to then the much stronger claim that that was the only intention at all. And so I don't think we can point to the rest of the universe and see it as somehow as we can see that it's obviously not relevant to the existence of life, right? In the empty stretches of space or galaxies that are uninhabited. That doesn't further the end of intelligent life, but it may further some other end. And how do we rule that out as unlikely? So, zooming out then towards the end of our conversation here, I am a philosopher and you are a cosmologist. And I am interested in this question of how cosmologists or scientists more generally and philosophers are to relate to one another in this conversation about fine tuning, because clearly everybody's interested in it, and I have no desire to gatekeep to say, well, this is what scientists can talk about and this is what philosophers can talk about and they've got to stay separate. I think that's unworkable, if nothing else. Rather, we all just need to study the relevant tools, whether we call them philosophy or science, do our due diligence to investigate every aspect of the problem and contribute our analysis and have the conversation. But that being said, there's one specific question that bothers me and that I don't have a good answer to. Namely, should we think of theism or design, in this case, as a scientific hypothesis, as a scientifically respectable answer to the fine tuning problem? Because scientists clearly care about figuring out the truth. They want to know what it is that explains fine tuning. And let's say that we're in that possible universe, possible world where, just for the sake of argument, imagine that we are in that world where God or a designer brought the universe into being and fine tuned the laws of physics. In that case, if we say that there's somehow something scientifically illegitimate, intrinsically problematic about a design hypothesis, it's just not scientific, even if true. Well, then what is a scientist to do as they go on investigating fine tuning? They will never arrive at the truth. They will continually follow paths that lead to nowhere, or if they lead somewhere, they don't lead to the answer to fine tuning. But even so, I'm uncomfortable saying that theism should ever feature in a journal of physics or cosmology. Now, given that you're a cosmologist who thinks about these similar questions and thinks that theism is plausible, how do you construe the relationship between God and science in this case?
That's a good question. So I think I guess something that took me a while to understand as someone who's like a young physicist going up through the ranks of physics, um, is that I think what a lot of my atheistic colleagues essentially at heart believe or want to be true, and maybe they wouldn't say it this way, um, is that they want to say that physics is metaphysics. That there's sort of no gap between them. That there's nothing outside the realm of physics that should belong to this thing called metaphysics. And one of the implications of this, I think, is that they, if you want to try to say that, is that you really need every aspect of a solution to fine tuning to be what you would call a physical solution. Um, so first of all, what that's going to do is it's immediately going to rule out um, like God, right? Because God is not God doesn't fit into this like narrow regime of like what is called physics, which is sort of like a mathematical description, I guess. Um, but not only that, and where I started to really notice this um, is that I think to me it is something I already said is it's not hard for me to imagine if I were an atheist. I somehow have to make peace with the fact that this universe just exists and it is the way it is and that's it. Um, why can't I just therefore be at peace with saying, well, maybe there's lots of other universes out there that have different laws, right? Um, but what I've found very often is that atheistic physicists don't like that. They don't want to just say that these other universes exist. They need to somehow couch their existence in terms of this like eternal inflation plus string multiverse framework. In other words, they don't just want to say that these things could exist out there as other entities. They need to somehow like bring them into a single theory of physics that describes all of them, because physics is metaphysics, right? Anything that could exist, there must be some physical explanation for its origin. So I think that I guess where I would depart from that, and I think where I would depart from that, even if I were an atheist, is that I recognize that there could also be just questions whose answers are not physical in nature. And that's not to say that they're like supernatural, even. It just may be that there's some other realm of metaphysics out there, which is the thing that's in charge for answering these questions about existence. Why do certain universes exist? Why don't others exist? That maybe there's some metaphysical answer for that. Now, as a theist, I think that that's where I really get pushed towards God. That I think that some of these metaphysical questions, it's hard for me to come up with an answer that doesn't involve some sort of God, some sort of designer, some sort of being that's at the heart of it. Um, but I think even if that isn't your view, even for an atheist, I think that there needs to be room for some sort of metaphysical explanations that don't necessarily fit into like how we typically understand scientific theories, which is usually just some sort of like mathematical framework. Um, so I guess that's kind of my idea, and I think I'd agree. I don't maybe view God as a scientific hypothesis necessarily in the same way, um, but I also don't think that that means that it's wrong, because I think that sometimes what the physics is actually telling us is that we need some sort of metaphysical explanation that goes just beyond the equations that we know how to write down.
So where does that leave? And this will be my final question. Where does that leave fine tuning and the quest for an answer 100 years from now, or 500 years from now?
Yeah.
Again, in this possible world where God really did fine tune the constants, what does science look like in 500 years in terms of the quest for fine tuning?
Yeah.
Has it given way to a more unified inquiry into the fundamental nature of reality, where what we call metaphysics and physics aren't cleanly separated? Or are we still dealing with scientists who for 500 years have been going off in a direction? Okay, hold on. Let me get my dog. One sec. Interrupting my profound analysis.
Yeah.
um, so, yes, 500 years from now,
Yeah.
are we left just with these poor, hapless physicists who are confusedly looking for an explanation that isn't there?
Um, I think it's likely that yes, that will still exist. I mean, I think that what we'll probably see is sort of incremental progress in understanding these questions, because I guess I think that there are still plenty of scientific questions to be answered when it comes to fundamental laws of nature. One, for instance, we started out talking about is, how do you describe quantum gravity at the beginning of our universe? How do you describe the Big Bang? And I think I think 500 years from now we'll have a clearer picture of that, and I think we'll probably have a clearer picture of fine tuning and of the fundamental laws of nature. Um, but I think that there are just some questions that are not, for which science is not the best answer to, for which metaphysics and philosophy and theology are important. And so I think that if people are going to keep trying uh, to attack those with science, if people are, if the only tool you have is a hammer and everything looks like a nail, if people keep thinking that all of these questions are nails that the hammer of science is made for, um, then I do think that there still will be like debates and discussions about things we don't understand very well, because people are trying to use the tools of science where maybe they don't belong.
Hmm. Hmm. Well, that's a good point to end on. Uh, Thank you, Tom, for coming on the channel. This was a really interesting conversation. I think people will like it, and I appreciate you taking the time to talk with me.
Yeah, thanks. I really appreciate it too. Yeah, thanks for having me, and good luck.